We will continue our lesson with these three subtopics, still under the first order circuit. We start with unit step function, then continue with step response of RC and RL when unit step function is applied in the circuit. The unit step function represents a switching signal. Figure 1, switch is on at t equal to 0. Figure 2, switch is delayed at positive t0. And the third figure, switch is advanced at negative t0. Unit step function represent an abrupt change, such as in voltage source. T less than 0, the switch is connected to A and B port. But when t equal to 0, suddenly the switch is connected to the voltage source, represent the abrupt change. Similar condition we can see in current source here. Abrupt change for the current source. Okay, this is the meaning of step response RC circuit. Behavior, or we want to analyze the parameter when the excitation is the step function, which may be a voltage or current source. We want to analyze the parameter of RC when voltage and current source is suddenly applied in the circuit. Consider figure A. This is the basic circuit of step response RC. This circuit looks like source-free RC circuit, but the difference is voltage source here exists when t equal and more than 0. Compared to source-free RC, V source exists when t less than 0. So when switch is on at t equal to 0, this figure will transform into this. In the initial condition of the voltage, or V capacitor here, V0 minus is the condition of voltage when t less than 0. V0 plus is right after the switch is on, referring to the voltage capacitor, and these two are equal to the V0, or initial voltage of the capacitor. So in order to find the Vt or V capacitor when t more than 0, meaning that this condition or this circuits, what is the value of Vt when the voltage is keep charging the capacitor. So by applying KCL, we can do the equation C dV over dt plus V minus Vs u t over R equal to 0, and this ut represents the unit step function. We continue the differential step and integration, and finally we will get this purple blocks equations. Vt equal to V0 minus Vs e negative t over tau plus Vs. Vs here is the voltage source that exists in the circuit, and tau here is RC, and this is the condition when t more than 0. Okay, this is just the derivation step to get the purple box equations. Okay, we can write in this time domain in time sections. T less than 0 or t equal to 0, initial voltage, assume capacitor is initially charged, the value is V0. If it is initially uncharged, the V0 is equal to 0. Okay, and this is when t more than 0, Vs. Just copy back the value equation in the purple box, same like this one. Okay, like I mentioned earlier, if it is uncharged initially, V0 is 0. So t equal to 0, also V0 is 0. Okay, here this is initially uncharged. This if there is a number here, means that the capacitor is initially charged. usually will be given whether the capacitor is uncharged or initially charged will be given in the questions. So if let's say if it is uncharged initially, so V0 here will be 0. That's why this equation will be simplified to this one, and we can use this equation, simplified equation. But if you don't know, just use this purple box. Just replace V0 here, 0, and you will get the same equation. You will get the same value if you use this equation. This is same like this one, yeah. Just replace V0 here is 0. Under category initially uncharged. Okay, the graph of complete response of step response RC looks like this. Start from 0 until finally at certain time or at certain period, the Vs will be saturated. The value of capacitor will be saturated, and here the detailed explanation about this term Vs is when final value at t more than infinity. Represent here infinity, maybe time will be reached to up to infinity. V0 initial value at t equal to 0, and Vs here is the source free response. Or the complete response, natural response, we can transform this equation into this one. V0 E negative t over tau, and Vs here factorize, expand the equation, transform to get into this one. We call it this Vs1 minus E negative t over tau force response independent source. Okay, similar like this slide is detailed explanation on this step response of RC graph, which explain about natural response and also force response. Okay, also it can be written in this form from the same equation, yeah. Just transform into here. This is what we call steady state response, and this is transient response. Steady state response means that the behavior of the circuit a long time after an external excitation is applied, meaning that this condition the voltage is already saturated. And transient response is the circuit temporary response that will die out of time. Transient response is referring to this condition, this part, transient. Okay, 3 steps to find out the step response of RC. Find the initial capacitor voltage first, whether it is initially charged or initially uncharged. Second, find the final capacitor voltage V infinity or V saturated for DC voltage source is here, V0, V infinity here. And the last one, find the time constant tau is equal to RC. So Vt, this is same, just this slide just write back the purple box equation. Vt plus equal to V infinity plus V0 minus V infinity E negative tau, negative t over tau. Let's see example 7. The switch in figure has been in position A for a long time, and at t equal to 0, switch move to B. Determine Vt for capacitor for t more than 0, and calculate V 1 second and V 4 second. First, we can divide this circuit into 2 conditions, which is when t less than 0, only this component involved. So the circuit will be like this: 3K, 5K, and this become, as capacitor here, this become open circuit. So V capacitor here refer to the V 5 kilo ohm. So this is the conditions when t less than 0. And when t more and equal to 0, so t equal to more than 0 is the switch here from A shifted to B. So the circuit 30 volt 4 kilo ohm, this become still open circuit for the voltage capacitor. This is 30 and this is 4 kilo ohm. This is after t less than more than 0, this is the t less than 0. The detailed solution of example 7 is explained here. Like the circuit I drawn earlier, when t less than 0, V here is open circuit, so we know we are interested to find the V capacitor here, and we know that VC here is parallel with the 5 kilo ohm here. So we can straightforward use the voltage divider and we will get the 15 volt. So this is the initial voltage of capacitor, or the voltage of capacitor when t less than 0. Next step, we want to analyze, or we want to find the voltage capacitor VC when t more than 0. It is the same. You can write VC t, refer to the condition t more than 0, or you can write V infinity. It is the same. So here is open circuit. So VC here is same like the voltage source 30 volt, because there is no voltage drop at 4 kilo ohm. No current can flow through this resistor because of open circuit 30 volt. And tau here, how to calculate tau? Just include the resistor that exists in the circuit for t more than 0. For this condition, we don't want to include, we don't want to consider. Just consider the resistor that exists in the circuit when t more than 0. Straightforward. Use the R equivalent here, only 4 kilo ohm times with the capacitor. This value is given in the questions. You will get tau here 2 seconds. And next step, you can write the equations and insert the values that you have found. V infinity is 30 volt, V0 is 15, and tau here is equal to 2. So this is the final answer for Vt, but the question asks for t equal to 1 second, just insert the value for 1, and this is 1. So calculate with your calculator, you get this answer, and V at 4 seconds, you get 27.97. Let's continue with example 8. Find Vt referring to the V capacitor for t more than 0 in the circuit below. Assume the switch has been open for a long time and is closed at t equal to 0. Calculate Vt at t equal to 0.5 seconds. So again, we have to divide this, or we have to analyze this circuit under two conditions: t less than 0 and t more and equal to 0. So t less than 0, the component involved here are only this, because the switch is open, so it is open circuit, yeah. So the circuits will look like this. Here is the V capacitor. V capacitor here is the V initial. Will be the value will be same like 10 volt here. T more than 0, since this becomes short circuit, so all the components are involved in this circuit. Two source of voltage, two voltage source, one capacitor, 2 ohm, 6 ohm, and the switch. We don't have to draw back the switch, just draw short circuit here, draw the connected line here. So just analyze the voltage capacitor of when there are two voltage sources. The solution is detailedly explained in here. This is when t less than 0. We are interested to find the VC here. Since there is no voltage drop at 2 ohm, so VC is equal to 10 volt. Straightforward. The initial voltage. So now we want to analyze the circuit. This circuit when t more than 0. So when t more than 0, there are two voltage sources exist. We can use the superposition principle. What I explained here currently is regarding on this part, yeah. This I haven't touched yet. Okay, in order to find the voltage here, we need to use superposition principle, which we analyze one voltage source at one time, and the other voltage source we disconnect or we turn off, yeah. So let's say we want to analyze this 10 volt first. This is 2 ohm, and I just want to write 6 capacitor here. This open circuit and 6 ohm here, and to disconnect 50 volt means that we want to short circuit the voltage source. Okay, disconnect or turn off the voltage source here. So this V capacitor here is equal to V6 ohm, or maybe the easier way how to analyze this circuit, if I draw like this thing, 2, 6, and this is the capacitor. I change the capacitor at the last of the circuit. Still 6, maybe the short circuit V0 here is occurred here, maybe somewhere here, but this is just short circuit. So V sim, this circuit is same like this one. I just change the capacitor at behind or at the last component of the circuit, so that you can obviously see, or you can clearly see that VC here is equal to V6, since it is parallel connections. So just use the voltage divider, 6 over 6 plus 2 times with 10 for the voltage source V1. So for the second part, if you still remember that the superposition principle, let me erase this first, this voltage 10 volt first. Okay. So if you still remember that in superposition, when we want to add the another analysis, we use plus, right? But this use minus. It is because the voltage here is already changed from the questions earlier. Is the polarity looks like this, but here it draws like this. That's why it changed to here, negative. But if you want to proceed with the same like in questions, negative 50 volt, okay, write this positive here, and then this becomes short. This is 2, and then this is capacitor. This is our 6, and okay, 50 volt. That's why 2 plus 2 plus 6, negative 50. So that the difference between our solution and these solutions is plus here and negative 50 here, but it will produce the same number, which is negative, still negative here. In this figure, we stick the polarity like in the equations, and we stick with the superposition plus, but in this solution, it changed the polarity of the voltage to become like this, but it has replaced the plus here to become negative. But both methods will produce the same answer. And finally, this part is added and we'll get negative 5 volt. Okay, next we have to continue and answer the questions. Finding Vt at t equal to 0.5 second. After we found the V infinity, refer to the position t more than 0, V0 plus minus V infinity e negative t plus tau. This is of course under initially charged condition because V naught here is not 0, yeah. So this is 10. So directly we can get the answer here. So at t is equal to 0.5, just insert the t, and we will get V capacitor at that time at 0.5 second is 0.5182 voltage. Oh, before that, maybe I forgot to explain on this tau. Yeah? Tau here, since tau is equal to R equivalent times C, R here is 2 parallel with the 6. We cannot consider that 2 in series connection with the 6 because there are 2 voltage source and the current flow at 2 ohm is different with current flow at 6 ohm. So when different current flow means that the series are in parallel connections. The same current flow, it is series connections, but different current flow, it is different. It is parallel connection. Okay, and that's all for example 8.